Welcome to lecture number 33 for ECE 476 Advanced Embedded. In this lecture, we're going to look at using your Raspberry Pi Pico as a Wi-Fi server in AP mode and send data to the Pi using tags. Now, in the previous lecture, we looked at setting up the Raspberry Pi Pico in AP mode. That creates a wireless network that other devices can connect to, like your cell phone, a computer, whatever. Once you're connected, the previous lecture looked at how the Pico can send data to those devices by modifying a web page. In this lecture, we're going the other way around. We're going to have devices send data to your Pi Pico. And with that, I can send text, commands like click on buttons, turn lights on and off, and let's give an example of that. So here I have a program that we're going to be looking at a little bit later on in this lecture. This is using a tag. The tag is a web page where I have inputs that sends data back to the Pico. On this program, I can control the LCD display. So suppose I want to set the color to red. I do color to 5000. Submit. The Pico just received that as 4 numbers. There's the color to 5000. I can now send a command like clear. That'll clear the display. As you can see, the display has turned red. There's your red, green, blue. That's a little bit bright, so let's do color 0020. I can clear the display. I can draw a box. From 5, 450, 300, 200. Draw a circle, centered at 200, 150, radius of 80. So basically, I can send different commands to the Pi Pico. With that, it's kind of up to you and your creativity what you do with that. So how do we do tags with the Raspberry Pi Pico? So what we're doing in this lecture is we're building upon what we did last lecture. Last lecture looked at how to send data to a client. This is how to send data from a client to the Pico. And we're doing that using tags. The types of tags we're looking at are text fields, number fields, checkboxes, and push buttons. Now, there's many other types of tags. If you go to W3 schools, they've got like 2 dozen different types of tags you can use. The 4 that I'm presenting here are 4 that are pretty useful. They're basically the 4 that I got working, but there are other options. The nice thing about W3 schools as well is they have interactive windows. You can try out your HTML code to see how it works, so you don't have to sit there and keep on downloading it to your Pico board, trying to debug it. So again, highly recommend W3 schools. So let's start out. Start out with a text input. What a text input does is I've got this text window. I can type in whatever I want. It can be words, integers, floating point numbers, whatever. When I hit submit, the data is submitted back to the host. Once the host gets the data, again, the host is going to get that as a text string. I can convert it to an integer or floating point number in Python. The starting point is you need the HTML code that sets up that web page on the client. The text code comes from W3 schools, based pretty heavily on that. This sets it up. So here's your HTML document, here's the start of the body, end of the body, here's the heading. The form is a text box. Ended by submit. I've got a text frame labeled N0, a text frame labeled N1. When I hit submit, the data in that window gets echoed back to the Pi Pico. The second step is I have to pull that into my main routine in Python. This is using what we did before, using a subroutine called webpage. Webpage simply opens up that text file, strips out the character and line feeds, returns it as a text string, and then the main routine will echo that back every time I get a ping. The next step is in the main routine, I need to open up a Wi-Fi network in AP mode. So here's the ID and password of the network. This opens up an AP network, waits until the network is active. This will tell you the web address you need to connect to, open up a socket, and lock that socket. And this allows up to 5 different clients to connect to you. Once the network is open, I start the main loop. What the main loop does is this guy right here, it waits for a ping. Waits for somebody to connect to me. Once it does get a connection, it says who connected to me. It sends the data from the ping, prints it on the shell window, echoes back the web page, and then closes the connection and repeats. That's kind of how it works over and over again. It opens a connection, gets the response, pings back, closes the connection, repeat. Now if you do that in the shell window, what you're going to get is something like this. Every time I hit send or submit, I get this message. A lot of it has information that I don't care about. This is the web address of the client, if I care. This who was talking to, that's me. I don't care. All this other stuff, blah, 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 blah. The line that starts with refer, that's what I care about. So it's go through this entire response, look for the keyword refer, and there's the line that has the information. This is the message that I just sent back. I sent back 1234, 123.456, 789.012. So what I'm going to do is I'm going to strip out the message, only pull out the part that starts with refer, then pull off everything to the left of the question mark. The different fields will be separated by the and sign. So I've got my message 0, message 1. So this is just pulling out that line of code, looking for the PHP question mark, looking for the character return line feed, that's the end of the line, and I wind up with this guy. To pull out the different fields, I look for the and, that's right here. Every time I see an and, that's a different field. That was your message 0, message 1, message 2. After all that, when I send a command, I'm going to get message 0 equals, and here's the message. Message 1 equals, and here's the message. So every time I type in something different, I get a ping back, just one ping, saying here's the data that I sent to it. Now if I send a space, space shows up as a plus sign. You can see that over here. Go over to Thani. Here's my web page. I can say 1, 2, 3, 4, 5, 6, 7, 8, submit, and there's the data. And actually here I did a little bit more. I also stripped off everything to the left of the equal sign. So that's why you don't see the equals. If I type in something like hello world, the space shows up as a plus. If I type in hello plus world, the plus shows up as %2b. That's ASCII plus. So anyway, I've got numbers or text I can send back to the main routine. Do whatever you want with it. Next type, let's look at a number field. Now, a number field is like a text field, but you're limited to integers. It has this convenient little up-down arrow, so you can increase the number, decrease the number, or just click on it and type it in by hand. When I hit submit, I'm going to get 3 numbers. So just like the previous solution, but you're limited to numbers. What the HTML code looks like is this. This code generates that field. So here's the heading. This is an action page, I have a number type input. So the first one's going to be red, then green, then blue. When I do that, when I hit submit, I get this. If I type in 163164, there's your RGB equals, and there's the data. So to illustrate that, so if I do a couple numbers, 2, 3, 4, and this is slightly modified, I strip out everything to the left of the equals, so instead of getting R equals, G equals, B equals, I just get 2, 3, 4. You can type in the number. Okay, went past the maximum. And there's your data. That's the number field. Next AP window, a checkbox. With a checkbox, this would be like select all the ones you want. You can select 0, do as many boxes as you want. Then hit submit. So again, like this would be like there's 3, vote for 2 candidates, pick 2 colors. The HTML code is same as before, an action page, but this is a checkbox. We've got the different colors, red, green, blue on. What gets echoed back is red, green, blue. When I submit, it tells me which ones were checked. So if I don't check anything, I get a blank page. If I just check the red box, I get color 1 equals red. If I check the green box, I get color 2 is green. If I check all 3 boxes, I get red, green, blue. That's a checkbox. Radio button. Radio button is similar to a checkbox, but you can only select one. So this would be like vote for candidate for the Senate, for the House. You can only pick one. If you leave it blank, you just get a blank field back. The code is an action page for a radio, meaning only select one box. And here's the different categories: cats, dogs, ferrets. Next one, lions, tigers, and bears. Oh my. And the return data is if nothing is checked, you get nothing. If I check cats and lions, I get the first message, 0th message, first message, cats and tigers, ferrets and lions. That's the radio button. Another type is a hyperlink. Now, hyperlinks are normally used to return web pages, but you can also use them to return data. If you click on the hyperlink, the data gets echoed back. For example, if I want to create this type of web page, when I click on turn on, the light turns on, turn off, the light turns off. The code would look like following. I have an A, that's the symbol for a hyperlink. And there's the end of the hyperlink. This is going to tell me, well, when I do a hyperlink, I have to echo back to the AP host, its address, and the message I want to send. So this guy, I don't really know what it is. When I write the code, I'm going to use a dummy variable. And I'm also going to have this dummy variable saying that the current status of the LED is on or off. Inside the web page, I need to strip out and replace those dummy variables. So we need to pass to it the IP address and the status of the LED. And I'll then replace AAAA with the IP address, BBBBB with the LED status. Then in the main loop, can only respond to the FAV icon pages. I'll look for the symbol refer, +9 to get rid of all that other crap. look for the keyword to turn line feed. And for this message right here, I then actually want to pull up this field right here. So what I'm going to do is look for the backslashes, strip off everything to the left of the backslashes, and eventually I get my message. So that's my message, light on or light off. Then in the main routine, I can actually do something. If I got the request of light on, I can turn on a light, light off, turn off a light. I can also echo back, what is the status of the light? Is it on or off? So that every time I click on light on, the light turns on. Every time I click on light off, the light turns off. Kind of one-side light, the LED status is always one click in the past. Not really sure how to fix that. Okay, so let's show how that works. So here is the web page. I'm connecting to 192.168.4.1. That's my Pico board. I'm going to click on light on. You can see the LED turns on. Light off, LED turns off. On, off. And the status is actually always one old. So we do off again. LED is off. On. Second time it works. This is always one old. I'm not quite sure how to fix that. So we do off. Here goes. LED is off, but it shows up as on. On. LED is on, shows up as off. It's always one old. If I do double click, it's correct. Click, click, it's off. And what's happening is showing up in the shell window. It received the message. Finally, let's do hyperlinks with buttons. So with buttons, it looks a little bit prettier. This is actually going to be a hyperlink. When I click on this guy, it treats that as a link to another web page. But the web page is going to be the message on, off, and toggle. So similar to before, I'm going to have A, that means a hyperlink, but it's a button. And the first button echoes back by host name, the message light on, light off, light toggle. It's a button, and the value is on, off, or toggle. The data when I click it is going to be light on, light off, light toggle. Then in the main routine, so to illustrate that, if I click the button, the light is on. Now I got it. Light is off. Toggle. And in case I'm getting a double read, off, on. Nice thing about off and on is if you get a double read, it doesn't matter. Okay, so that's kind of the main types of tags you can use. What you do with that is kind of up to your creativity. As an example, I can use somebody else, like my cell phone or another computer, to connect to the Wi-Fi network and control the LCD display. So here I've set up a couple commands. I've got line, color, box, solid box, circle, and clear. If I want to set the color to pink, that'd be 200, 100, 100. It just accepted that as color, and there's the color, red, green, blue. If I then clear, using that color, I now have a pink screen. If I now want to have a box that's black, going from 5, 5, 470, 310. That drew a solid box. I can do a circle. do a circle that's white. There, did it. And circle in the middle of the screen, that would be 240, 160, 100. Again, I'm setting commands and controlling the Pico through a web page. So in summary, this lecture presents what I think is really, really cool. It's how to set up a wireless network with your Pi Pico. Other devices can connect to your Pi Pico on that network and receive data from the Pi Pico, like we did last lecture, or send data to the Pi Pico using AP tags. That was this lecture. This lets you connect to your Pi Pico even if there is no internet present. It lets you input binary numbers to turn on and off LEDs from your cell phone, browser, whatever you like. You can input floating point numbers, allowing you to vary the brightness of an LED, speed of a motor, color on the LCD display. And there's various types of tags you can use. There's many, many more tags exist and are presented on W3 Schools. The ones presented here are basically the ones I was able to get to work, but you kind of get the idea of them. And you could probably get the other ones to work as well, a little bit of effort. So that is lecture number 33 for 476, AP tags in AP mode.